An alternative definition to the classic definition of convex is to say that a function is convex if and only if f of b is greater or equal to f of a plus f prime of a times b minus a. So here we want to prove that that these two definitions are the same. Okay, so let's suppose f is convex. If f is convex, then f of alpha a plus 1 minus alpha b is less than or equal to alpha f of a plus 1 minus alpha f of b. That's the classic definition of what it means for a function to be convex. Okay. Now, if we rearrange the left side, we end up with, we have alpha a minus alpha b. So we've got b plus alpha a minus b, right? Breaking open this bracket and combining all of our alpha terms. That's, of course, less or equal to alpha f of a plus 1 minus alpha f of b. This we can rewrite as f of b plus alpha f of a minus f of b, combining terms in the same way that we did over in this bracket here. Now, this tells us that f of a minus f of b then must be equal to, not equal to, greater than or equal to, just rearranging this, the last line, f of a minus f of b is greater than or equal to f of b plus alpha a minus b minus f of b divided by alpha. Now, of course, this is for alpha in 0, 1, but if we take alpha to get quite small, then what we find here is that this is equal to f prime of b times a minus b by the chain rule. So this means then that f of a is greater or equal to f of b plus f prime of b a minus b, which is the same as our initial definition with the roles of a and b just reversed. Okay, so convexity implies, we'll call this equation 1. Convexity implies equation 1. we need to show that equation 1 now implies convexity to show that the two things are equivalent. So let's suppose that we've got a function let's call it f, just because we're using f's here. Let's say that f satisfies this equation here. F of b greater or equal to f of a plus f prime of a b minus a. And let's take a value z that's a convex combination of a and b. So let z be any convex combination of a and b. So it'll be alpha a plus 1 minus alpha b. Then by this rule here, we know that f of b is greater or equal to f of z plus f prime of z b minus z, right? It's equation 1 with z taking the place of a. We also know that f of a is greater or equal to f of z plus f prime of z a minus z. Again, same equation 1 with a taking the role of b and z taking the role of a. Then if we look at a convex combination of f of a and f of b, so alpha f of a plus 1 minus alpha f of b, we need to show that it's greater or equal to f of alpha a plus 1 minus alpha b. Well, it turns out that this is greater or equal to, if we look at the second inequality here, alpha f of z plus alpha f prime of z a minus z plus 1 minus alpha f of z plus 1 minus alpha f prime of b minus z. All right. Now, if we combine some of these things, we've got alpha f of z plus 1 minus alpha f of z, which gives us just an f of z. So this is equal to f of z plus, what else do we have here? We've got alpha f prime of z a minus z. So maybe it'll be easier if we break this up. So alpha times f prime of z times a minus alpha f prime of z times z plus 1 minus alpha, this should be f prime of z b minus z. Squish that in there. F prime of z times b minus 1 minus alpha f prime of z times z. Okay, so let's put these together again. You still have the f of z in the first term. You've got alpha f prime of a and then negative, well, maybe I want to do this a little bit differently. But if we add it up, we should end up with, let's look at the z's. We've got negative alpha f prime of z times z, 1 minus negative 1 minus alpha f prime of z times z. So we should have a negative z f prime of z. Okay, so that's part of it. And then we should have a plus f prime of z with the rest of this stuff. So it's alpha a and 1 minus alpha b. Well, if we clean that up a touch, that gives us f of z minus z f prime of z. And then alpha a plus 1 minus alpha b is equal to z. So it's plus, oh, there's a z here as well. F prime of z times, this guy is equal to z. So f prime of z times z cancels with negative z f prime of z, which gives us f of z. Which, if we really want to be explicit about this, this is f of alpha a plus 1 minus alpha b. So alpha f of a plus 1 minus alpha b is greater than or equal to f of alpha a plus 1 minus alpha b. And so equation 1 does in fact imply convexity. And so these two definitions, our regular definition and this new definition, they are in fact equivalent.